So welcome you all guys. So here today we are going to display, go do the exploratory data analysis of the uh, IRS project and IRS dataset to find the optimum number of clusters present in this particular IRIS dataset. So to do that, first we start with importing the important libraries. To import the important libraries that we are going to import will be the pandas, numpy, matplotlib, cbon, sklearn, skippy, and these are the particular libraries that we are going to import. So after that, doing that, we are going to check. We are going to read the data from the CSV file that will be the iris.csv. After reading the file, we are going to create the data frame for that this particular file, and after that we are going to display the data, some of the sample data for this particular from this particular data set. So this will be the sample data, and as you can see that there are only six number of columns and five now, and there are 150 number of rows. And after that we are going to use the information variable, or you can say the information function, to check for the to check and gain the more information about these particular variables. After that we are going to check for the missing values present in these particular columns. To check that, we are going to use the isnal function with the sum function. So here you can see that after running this function there are no no null variables or values present in any particular columns. After that we are going to check for the duplicated columns. There are no duplicated columns. And after that we are going to check for the any NA values present in any particular column. So there are no NA values present also. So let's begin with the univariate analysis of each and every column present in this particular data set. So let's begin with the first column, that will be sepal length in centimeter. First here we are going to check for the value counts. When value count function will tell us about the how many types of repetitive values of any particular type of sepal length in centimeters. So here you can see that this 5.0 centimeter length variable have the 10 number of sepals. So as we move on forward, there are various number of sepal lengths which will be repeated. So these are, after that we are going to check for the range of values of this particular variable sepal length in centimeters. To check that, we are going to use the max and min function and check the difference between them. After that, here we are going to check for the maximum values, minimum values, mean, median, standard deviation, and if there any particular value that is null in this particular column. So you can see that the 4.3 will be the minimum sepal length, maximum length will be 7.9 centimeters, and mean value will going to be 5.84 centimeters, and the median value will be 5.8, and the standard deviation in this particular column will be 0.82. And you can see that there are no null values present in this particular column. After checking that, here we are going to get the quartile values present in this particular variable. To get that, we're going to use the quantile function to check this particular quartile, and after that we are going to check for the interquartile range by using the stat function of the for the IQR range. So this will be the our first quartile function, that will be 5.1, and third quartile function will be the 6.4, and the interquartile range will be the 1.3. And after that we are going to check for the lower and the upper outliers. To check that, we are going to use the quartile ranges that we gained from the above line of code. uh, so these are the number of lower outliers present in this particular variable, and these are the number of upper outliers present in this particular variable. So this after going we are going to plot the box plot, disk plot, and histogram for this particular variable. As you can see that this will be the going to the this will be going to the box plot of this particular variable. This will be the disk plot, and this is going to be the histogram for this particular variable. After that we are going to check for the check same things for the all the other variables that are going to be sepal width in centimeters. You can check all the line of codes if you doesn't understand or doesn't able to tell what's going on the code, you can ask me in the comment sections. And these are the other variables that we are going to display, and this will be the third variable, the petal length in centimeters. uh, we are going to display all the same things that as we've done in the first variable, and this will be going to be the last variable, petal width in centimeters, that we are going to display for the particular univariate analysis. And this will be the graph for this particular variable. After that, we are going to create a copy of the data frame df in df1, and here we are going to drop the unnecessary column that are not required for the analysis, for further analysis. So the column id and the column species are not required for the further analysis, so here we drop those columns. So these are the particular histograms for the other columns that we are left with, that is the that are the sepal length in centimeters, sepal width in centimeter, petal length in centimeter, and petal width in centimeters. After that, we are going to check the skewness for values quantitatively by using the skew function with the within the df1 variable. So this will be the skewness of the particular four variables. After that, we are going to do the multivariate analysis by using the pair plot in the data frame df1. So this will be the pair plot of all the variables present in this particular data frame df1. After that, we are going to check for the correlation between the each and every variable, and we are going to use a transpose function because to get the information more presentable way. Okay, so here you can see that this is the correlation between each and every variable. So after that, to put this correlation is and get this correlation more visualization form, and better for better visualization, here we are going to use the heat map for each and every column of the where this particular data frame. So here you can see that the correlation between each and every variable of the this particular data frame df1. So after that, we are going to check for the significant correlation between each and every variable. So this will be the significant correlation between each and every variable. After checking that, we are going to check for the outliers present in the each and every variables of this particular data frame. So there are no outliers present in this particular variable. And after that, we are going to check we are going to display the box plot for each and every variables present in this particular column, particular data set, actually not column. So these are the going to be the box plots for each and every variable. Here you can see that these are the box plots. After that, we are going to plot the line plot for each and every variable to check that whether this data scaled properly or not. To do the clustering, before clustering we will apply the standard scaler and use to do the scaling of this particular data. As you can see that this data is not cleaned, because if this data is scaled properly, then these lines will be integrated with each other mostly, but these lines are highly separated from each other, so this data is not scaled properly. Now we will use the standard scaler to scale this data. Here we are going to scale this data. After scaling the data, we are again going to plot the line plot for this particular data. As you can see that now the each and every variable present in this data set will be is more integrated with each other. So here we can say that this particular data set is now properly scaled. So now here we are going to apply the clustering in this particular data set. So after for applying clustering, here I'm going to use the hierarchical clustering with the dendrograms to check for the clusters present, type of clusters present in this particular data set. So here we are going to apply the clustering, hierarchical clustering. So here you can see that after applying the hierarchical clustering, you can see this data is very messed up and you cannot read this data. To read this data, I'm going to use the truncate mode and get the more summary type of values for each and every type of clusters. Here you can see that this data is mostly clean, and now again we are going to use the apply the truncate mode in this particular data set also. After applying this truncate mode, you can see that the number of these are the number of data clusters we are going to get. So the total number of clusters that we are going to get in this particular column will be displayed in next further line of codes. But before that, we are going to create a new data frame that will be cluster df. That is the exact copy of the data frame, first data frame, that will be the df. So cluster underscore df will be here we are adding a new column in it. That's by the name of the cluster 3. Here we are going to display all the cluster type of clusters we are getting from this our particular hierarchical clustering that we applied. So these are the three type of cluster type 1, cluster type 2, and cluster type 3, and these are the frequencies for these particular type of clusters. As you can see that in the type of one cluster, there the frequency of clusters is 50. In type 2 cluster, the frequency of cluster is 3, and the type 3 cluster frequency of cluster is 97. As after applying that, in the conclusion, we came to know that after univariate analysis, the outliers present in sepal length in centimeters will be this and this, and these are the other outliers present in other leftover columns of the particular data set. And after that, at last, we to find the optimum number of clusters, where we have used the hierarchical clustering, and there we found there are three types of clusters, that is type 1, type 2, and type 3, and the frequencies of those clusters will be 53 and 97. So thank you all for listening myself, and if you have any doubt in any particular region of this topic or any particular section of this topic, you can ask me in the comment sections. If you have any queries, you can ask that also. And if you want to download this particular data set and this particular data column, this particular line of code, you can download that from my repository, and that I will the link to my repository I will provide in my description box of this video. Okay, thank you all for listening myself.